Power quality has become a major concern for all types of industrial and commercial customers. The intensive use of non-linear loads such as rectifiers, variable speed drives, UPS systems, computers and energy-saving light systems has led to harmonic distortion levels which are not acceptable for optimal operation. Too high harmonic distortion results in a reduction of productivity, reduces components' life, and can even damage equipment. Unbalanced loads such as PCs cause excessive current in the neutral, which may give rise to impermissible voltage levels between neutral and earth, and may result in physical danger and equipment malfunction. ABB is at the cutting edge of active harmonic compensation systems for both industrial and commercial applications. The ABB active filter PQF reaches unprecedented levels of performance for harmonic compensation, reactive power and load balancing applications, and is installed for a very broad range of applications worldwide. Let's now explain the active filter principle. The current drawn by a nonlinear load may be seen as a combination of a sine wave at the fundamental frequency and several harmonic currents. Those harmonic currents in turn create voltage distortion which affects the whole system. The PQF active filter is connected in parallel with the load and analyzes the harmonic current drawn from the network. It then injects the same harmonic current components as the load, but in perfect phase opposition. The harmonics are thereby cancelled, and only the fundamental current flows through the transformer. You'll now see a real demonstration of the ABB active filters performing harmonic filtering, power factor improvement, and load balancing. For the first demonstration, the load used is a 6-pulse thyristor rectifier connected to a DC reactor. This load generates about 80 amperes of harmonic current. The active power consumption is low and the fundamental current is mainly reactive. The PQFI active filter will now be connected in parallel with the load, and we'll observe the load current, the line current, and the filter current for different programming modes of the filter. We will also analyze the line current spectrum. First of all, the load is switched on without the filter. The load and the line currents are the same since the filter is not yet switched on. The spectral decomposition indicates a high level of 5th and 7th harmonic, as well as other higher frequency harmonics. The filter is now switched on. As no harmonics are selected, it will just be started up, but will have no effect on the system. The load and line currents remain the same. The 5th harmonic is now selected. The active filter will only filter that harmonic component. As the filtering target is set to 0, the filter will take out the entire 5th harmonic generated by the load. The spectral analysis clearly indicates that the 5th harmonic has disappeared from the line current waveform. The filter current is a sine wave with a frequency which is 5 times the fundamental frequency, and the resultant line current is a cleaner sine wave. The filter is then programmed to filter the 7th harmonic completely. The corresponding bar of the spectrum disappears, and the line current is even closer to a perfect sine wave at the fundamental frequency. We shall now select all the harmonics and perform maximum filtering. All the harmonics disappear, and the line current is now a clean sine wave. The filter can also be programmed to compensate reactive power. This can very easily be done from the computer or the PQF Manager Filter User interface. Since the fundamental line current is mainly reactive, the fundamental current will disappear from the line. The current waveform of the active filter is now exactly the same as the load, but in phase opposition. In a real industrial application, only the active current would be flowing in the line. The active filter was performing maximum filtering and reactive power compensation. We will now deselect the 5th harmonic. This means that only the 5th harmonic is flowing in the line. The same happens if we only deselect the 7th harmonic. Only the 7th harmonic appears on the spectrum and in the line. Finally, we'll stop filtering and only perform reactive power compensation. The active filter current is a sine wave with the fundamental frequency and only harmonics flow in the system. In a second demonstration, we will now show the load balancing features of the PQF 4-wire active filters. A single-phase harmonic load is connected between line 1 and the neutral. As a result, the supply current is highly unbalanced and distorted, with about 60 amperes flowing in line 1 and the neutral, and about 5 amperes flowing in the other lines. The filter is then switched on and is programmed to filter all the harmonics. The result is a clean supply current, which however is still highly unbalanced. As a next step, the filter's balancing features are selected. This results in the supply currents becoming virtually identical. At the same time, the neutral current is reduced to a negligible level. This feature of the ABB 4-wire active filters makes them ideal for applications where neutral conductors have to be offloaded and problems due to excessive neutral-to-earth voltages have to be addressed. These demonstrations clearly illustrate the flexibility of the ABB active filters to compensate harmonics, perform reactive power compensation, and balance loads. But the PQF has much more to offer. Filtering of harmonics up to the 50th order. Simultaneous filtering of 20 individual harmonics with 3-wire filters and 15 individual harmonics with 4-wire filters. Target limits for each harmonic can be preset. Filters using closed-loop control systems ensuring best accuracy. Direct connection up to 690 volts for industrial filters. Automatic derating function for applications where the switch room temperature is too high. Easy-to-use graphical user interface incorporating a variety of network measurements. Remote communication possibilities. Thanks to these features, the ABB PQF filter range has unprecedented high filtering efficiency and can easily be used for even the most demanding applications. ABB's PQF range of active filters is the best solution for your power quality problems. ABB PQF active filters. Cleanse your system beyond expectation.